Because I fell again. That's what happens when you fall once, and you're stubborn, and you're like, I'm just going to play through the pain. You fall again, on Monday, on campus, in front of a bunch of teachers. Yeah, I went down. Again, and then I go back up, because that's how I bounce. All right, so I just want to make sure that you either have it in your notes or you're going to have it to reference. We've got the fundamental theorem of calculus, which says f of b equals f of a plus the integral from a to b of f prime of x dx. Rarely does the College Board say, hey, go use the fundamental theorem in calculus, but this is one of those problems where they're going to ask you for the value of the function. I always think of this as like the final value. F of a is your initial value, and your integral represents your total change. That's the fundamental theorem of calculus. We use it all the time. Position problems, stuff like that. Now, there's another version that says the integral from a to b of f of x dx involves finding the antiderivative, evaluating at the top endpoint, minus the antiderivative evaluated at the bottom endpoint. You know when we do this? All the time. When you're doing a definite integral problem, right, and I say, hey, go find the integral of x squared from 0 to 2, what do? You find the antiderivative. You find big F. Well, what's the antiderivative here? 1/3 x cubed, and you evaluate from 0 to 2. So you're going to be like, oh, I plug in 2. Minus, I plug in 0. That's the fundamental theorem of calculus. Now you've got the second FTC, and I want to make sure this gets left up on the board for a while. The second FTC, that's always the scary one. It looks something like this. You're taking the derivative of the integral of a function from a constant to a variable, and what happens? You get f of x. It looks scary on the front end, and some of you get overwhelmed when you see this, and you're like, what am I supposed to do? Plug in. That's it. And then there's the extended version, the derivative of the integral of a function from a constant to some other function. This is f of g of x times g prime. Fundamental theorem of calculus, second fundamental theorem of calculus. That's where we're spending the rest of today. All the friends are good? Yeah. All right, so let's do this. Ooh. All right, on page 55. 55. Okay. Nobody should have done this problem yet. I'm going to come around. I'm going to take attendance. I'm going to check that you did the homework. Have your orange card ready for me, please.
Would you just like us to go to your desk instead? Like just bring one to my table to bring it to you?
Oh, no, it's okay. I want to get my 10,000 steps. I still have goals.
Oh.
Yes. I will hurt myself to reach my goals.
Don't do that. Literally.
No, it's actually not. I do enough laps in the classroom. I hit 10,000 steps by about noontime.
Oh, really?
Yeah. Okay, because evil is everywhere. You guys okay. All right, so you guys have a couple minutes. Get started on this. Use your notes from the video. Help one another. Capitalize on all these smarticle particles. I'll come around in a bit. 4, 8, 9, 12, 15, 19, 22.
Let g be equals to g of x equals -3 15. Oh, this is F. So like the x is zero is just basically two t's.
So G0 is just plugging 0 to the x.
Because you're not doing the interval. This is one of the
Yeah, so from -3 to 0, isn't that a tricky one? 1 prime base 1, which is 2. Comes
Magic the
right,
check.
it's
I know you're fun.
3, that's 9.
You never you do.
This is what this is, bro. Saying that G is 0 is the same as times over here.
Every 2. Okay.
I didn't know one.
Oh yeah.
All right.
And you were absent Wednesday, right?
Yep, got it. All right,
You say
so last stop here.
you understand the problem? I know so. Yeah, no.
Yeah, I've asked them. Yeah, me too. Oh, you put it at I did like
Oh.
yeah, that's what I
All right. I know I've still got some folks to check in with in the back. Don't worry. Okay, G of 0. Be careful. This is the graph of f. G is the integral from -3 to x. So G of 0 is the integral from -3 to 0. F of t dt. That means I need area from -3 to x equals 0. That should be 1/2 times 2 plus 1 times 3, which is 9 over 2. And everybody good? Okay, now G prime of 0, you gotta be careful. You gotta be careful. I need to see 2 steps here. I have to see both. First is you show me G prime of x. Well, that's the derivative of your integral. And what happens there? Derivative of the integral? Yeah, this is just f of x. Now that I've made this connection that G prime and f are the same thing, now go find G prime of 0, which is f of 0, which is 1. I know G prime of x equals f of x, so G double prime of x must be equal to f prime of x. G G double prime of 0 is F prime of 0. What's F prime of 0? F prime does mean go find the slope. But if I look at the graph of F, there's something wrong here. You have a cusp point. So F prime of 0 does not exist because F has, not is, F has a cusp point at x equals 0. You could earn 1 point for coming up with the answer of 9/2, or of course you can stop here. You get 1 point for connecting G prime and F of x together. G prime of 0 is equal to 1. G double prime equals F prime of 0 gets you a grand total of 4 points. I'm curious, how many of y'all would have picked up all 4 points? Okay, 3 points. Okay, folks that are not getting all the points, where are the mistakes coming from? Henry.
I forgot that when you do G prime and then d over dx is equals f of x.
And unfortunately, this is going to be a critical mistake, because if you don't see this, you don't make this connection, you're not going to get the rest. Paul? You didn't see the cusp point, okay? So you had like some number here for the slope, maybe?
Yeah.
Okay, any other issues? For the most part, is everybody okay? Michelle, you feeling good? All right, keep going. I'm going to stop you guys from working on this one at 9:25 so I can pass back the progress monitor. We can celebrate the excellence that has happened. Oh my goodness. It's like being on Oprah. It was so good. I can't wait. I did signatures for everybody in the front. Back to the back.
So equal to f(x), so increasing release that this way. No.
So doesn't that mean that G prime of x changes from the
Or
positive
you'd be like g of x increases and g prime is 0. And you know g prime is equal to f.
And since we know that like
Okay, look, you want g of x increasing, right?
equals f
And you know that whenever g of x is increasing, g prime of x has to be greater than 0. And you know that g prime of x equals f. G prime of x equals f. You just use it. Oh, I understand it all right now. Okay, good. Yeah, it's above that. There.
x equal 1. I mean, yeah, 1 no, maybe.
So,
Oh no, yeah, no.
yeah. 3? Yeah. Or is that -3? -4. You got that?
If this is increasing, G prime is positive. Oh, that's not 2.
Oh yeah, that's true. Yeah, we took it. So G, yeah, it's like it's increasing G and G has to be greater than 0. So that means from like 4 to 3. Yeah, 40. Negative 40. Negative 40. Es que se me rompieron por el medio.
So where g changes where g prime
So like
If you're adding volume, you're on.
well,
Alright, everybody keep going.
so that means this would be a relative miss.
Está negro. I'm like, oh my god. Also, like whenever I say Wendy's name, yeah, it's espantosa. Yeah, she's very nice.
The second fundamental theorem of calculus, the only time you're going to use it is when you talk about the derivative of the integral of a function.
So many X
That
theory.
derivative and integral combination together, that should be screaming second.
I don't know what sexy in there.
Alright, for anybody who's interested, G increasing means that G prime, which we know to be F, is positive. So we're going to be positive from -4 all the way to 1, and then from 1 to 3. Okay? 1 point for the statement, 1 point for the integral, for a total of 2 points. There is actually a mistake for any of the calculus teachers that are seeing this. There's a mistake in the scoring rubric that's provided here. As soon as you say G prime has to be positive, then you cannot include, you absolutely cannot include x equals 1 because the graph isn't positive there, it's equal to 0. Everybody else that's in the room, are we okay with this? Okay, good. All right, I'm just gonna keep blasting through some of these. Part C, find all values of x in the open interval, -5 to 4, for which G will have a relative max. G has a relative max. Means G prime has to do something. G's got a relative max. Everybody needs to know. Rubio, what you got?
Change from positive to negative at x equals 3.
So if G has a relative max, G prime changes from positive to negative. Done. But G prime and F are the same thing, so where does G prime change from positive to negative? At x equals 3. Not 3, 0, 3. Just the x value. So this happens at x equals 3. Point. D. Find all values of x in the open interval, which G has a point of inflection. I'm going to slow down. G has a POI. If you haven't gotten there yet, keep working.
No, but you don't need. I don't need you to. Because
That.
that's for geometry. So that just means. Yeah. So the macro is this. But it's still a max though. Because they're just asking about this graph. Because it's not asking. Yeah, no, you can still use the question because it's not asking for.
X equals 0 then, or would that be 0?
Excuse me. Is that x equals 1?
And then x equals 2? Look at me, Mom. I'm
There you go.
Oh.
Testing. What do you think?
Jackie B. Sheila.
What's up, babe?
Bell.
We need to just
X equals negative.
Head off.
X equals 1.
Your son's not here.
Or
Perfect score.
Where'd the floor go? Oh, she's absent. Karina, Michelle,
I hope you know I added instead of.
Oh. They're on camera. Perfect score.
Axel. Axel's up front now, that's right. Sylvia.
What'd you get?
He does some.
Adrian. Rubio. Marilyn.
I missed it. I had doubts about this one. I thought it was from 39 to 40. Because I just wanted that point. But it was from 0 to 40. And I had 0 to 40 first. 79.
79. Friday the Ortegas?
Yeah, you know.
Friday the Ortegas.
Close enough to me.
Hey, look at so, okay, so I know this is.
We can only see from your neck up.
Oh, they can't?
So
They can't see my dance move? They can't see this?
All right, let's put all back together. Some of you guys are going a little buck wild.
Yeah.
G has a POI. That means that G prime, which is equal to F, has to change from increasing to decreasing, or the change is decreasing to increasing. Jesus, how are we feeling about this? Where does G prime, which is F, change from increasing to decreasing?
I think -3. X equals -3.
At x equals -3, I completely agree. The graph stops increasing and starts to decrease. Jesus, is that the only place?
No.
Where else?
X equals 2.
At x equals 2. Are there any other points of inflection? Points of inflection. Rubio, what you got?
At x equals 1, it goes from decreasing to increasing.
At x, I'm sorry, what did you say again?
The graph.
Ah, the graph.
The graph, yeah.
The graph, not it, never it. We're too late in the game for it. Where G prime, which is F, changes from decreasing to increasing. Everybody good?
Yes, sir.
Now, here's the thing. I really hope that A, B, C, and D, you're like, these are comfortable. I am good with these questions. You should be. And then there's E and F. All right, E. Find the absolute minimum value of G. That should strike fear in your heart. The absolute minimum value. Have a quick conversation with somebody near you. What's your plan? Absolute minimum value of G. How are you going to figure that out? Don't talk to me. Talk to your bro.
And then move on to the next person.
No, you don't just move on to the next one, Henry.
Aren't that like the endpoints part of
Always go for the easy.
Yeah.
Alright, what you do is
Alright, I want to get some brave soul. Where do you start? Where do you start this process? Julissa, where do you start?
you find your candidate?
You find your candidate, and when we say a candidate, the candidate for an absolute minimum means your relative minimum. Where does the graph have a relative minimum? At x equals where? At x equals -4. The candidate is x equals -4 because G prime makes a change from negative to positive. That's why I'm going to pick -4 as my candidate, but I'm not going to pick +3 as the candidate. That makes no sense. That's a candidate for an absolute maximum. Is everybody okay at this point?
Yes, sir.
Generally, I see you guys are good with the candidate. You also know that endpoints are important. The endpoints here are what? X equals -5 and x equals 4. Usually identifying the candidate and saying y is a point, and here's where things start to get scary. Now what?
You find the values.
You want to find the values. I heard you want to evaluate. Jackie, what do you want to do?
I was going to say evaluate.
You want to evaluate, but what are you evaluating?
So you put you evaluate your candidate and your endpoints to Gia.
The candidate and the endpoints. What is it that you're trying to find the minimum value of?
G.
G. So you have to, and Miss Blakely at East End does a masterful job with this. She does this little like table approach, and she says, let me list my values. -4, -5, +4. These are the places I'm interested in. Now I'm going to go over here and say, go find g of -4. Go find g of -5. Go find g of 4. That table seems to bring a lot of like structure for folks. Okay, Paul, how am I going to find g of -4? What are you going to do? You're going to plug into g of x. So what I'm really going to have to do here is an area calculation from -3 to -4, and you're going to get some number. You're going to do it again for g of -5, an integral from -3 to -5, f of t dt. You're going to evaluate g of 4. That's an area calculation from -3 to 4 of f of t dt. And whichever one is the smallest wins. Now, for the sake of time, I want to break this up a little bit. Rebecca's table and Jesus' table, I need you guys to work on coming up with the value for g of -4. Yvel and Marilyn's table, g of -5. Everybody else, g of 4. Take a minute, go find those values. I'd love to check it.
Oh, you was on the area?
Okay, that looks right. There is a mistake though. There's a fatal mistake. I want the absolute minimum value. Don't tell me x equals. Yeah, or you could just say the absolute minimum value is -1. Otherwise, right, if you say x equals, I'm thinking x coordinate. You could say at x equals -1. Okay. Right. Results are pouring in. I heard g of -4 is -1.
Yeah.
Okay. Did anybody find g of -5 yet?
0. No.
I believe g of 5 is going to be 0, and g of 4 is a tricky one.
Yeah.
Everything should cancel out. What'd you get? G of 4? I don't agree with 0.
I put 3 to
G of 4, you need the area from -3 all the way to +4. I don't see how that could possibly be 0.
Oh, I wrote 0.
You're going to go from -3. If it had just, even from 3 to 4, it wouldn't be 0. It would be a negative number. Okay? Let's see, we've already got this piece here,
9/2.
which is what, 9/2?
Yeah.
Okay, we got that. Then you need to find this area over here.
I gave up right there.
That's going to be a little tricky.
Yeah.
That's going to be a little tricky. Okay, here's what I know. I know that this guy here is some positive answer, and that guy here is some negative area, and guess what? They're going to cancel each other out.
Couldn't you do a rectangle first, take the area of the entire rectangle, and then subtract the
You could find the area for the rectangle and subtract out the half circle.
Yeah.
Now here's the other thing. What do you know for sure about this area?
Positive.
It's positive.
Yes.
So you've got 9/2 plus some positive number. Are we okay with that? Some positive number for sure. So what's the absolute minimum value? Uh-oh. Hear the question. What is the minimum value?
-4.
Not where is it? What is it? The absolute minimum value is -1. It happens at x equals -4.
Yeah.
Okay, lethal mistake. All right, last one. You guys are doing a great job today. Okay, part F. H of x equals the integral of square root of x to 3.
So I give up.
Why do they always do the hardest problem?
The second.
Okay, h of x is the integral of the square root of x to 3. F of t dt. Yeah.
I have a question. Can you so like in order, can you switch the the values so like you put into a
Okay. We need to find h prime of 4, which means we need to find the derivative at 4.
Yeah.
Now when I hear Daisy saying right away, she doesn't like this. You don't like having the square root of x in the bottom. Is it okay to switch them?
Yeah.
Absolutely. Good.
I
Nice
didn't
and
make it.
strong. Yeah. Switch them. Whoop. Switch them. Switch them and
Put a negative.
introduce that negative sign. Now to find h prime of 4, you have to find h prime of x first. So you need to find the derivative of the negative integral from 3 to square root of x,
Extended and
f of t dt.
extended second
That's this guy. Right, Jackie, the conversation we were having earlier of like, how do I know to use the second fundamental theorem of calculus? It's this derivative integral combination. Okay? Now the nice thing is what happens when the derivative and the integral come together?
So it's
It just equals,
F.
Basically they cancel out, if you want to say it that way, right?
oh, yeah.
Right, they're inverses of one another.
Yeah.
Derivative of the integral of a function from a constant up to here will be negative f of the square root of x times derivative of the square root of x,
1/2 square root of x.
which is 1 over 2 square roots of x. You memorized that a long time ago. We've reviewed it. That's your derivative. H prime of 4 is negative f of square root of 4 times 1 over 2 square roots of 4. F of the square root of 4, well that's really, what, f of 2? Do we know f of 2?
Yes.
Oh, thank goodness we know f of 2 is 1. So if all goes well,
Make it 1/4.
negative 1/4. And all the friends are good?
Yeah.
Okay. All right, at this point I'm going to turn off the video because I want to spend the last 15 minutes